working with field maps. So now that we know what field maps are and we know how to create them, let's talk about how we can use them to extract information. The first way that we will uncover is when we infer data points on a field map. What that means is on a field map like this, these are isotherms across the country or the continent of Australia. What is the value right there? What would the temperature be equal to? Well, because it's on the line that connects to 75 degrees, I can say it's a 75 degree Fahrenheit temperature on that line. And that would go generally for anywhere along this line. It's 75 degrees. We had talked about that. If that's the case, what is the value of this dotted line? Because it's halfway between 75 and 65, I can say with some degree of certainty that a value of 70 degrees would be okay for that line. Because on my map, it's halfway between. What if you were asked to come up with the value of a point right there? Now, there's no line drawn. It's in the middle of nowhere. And the only points you have to reference are the temperatures already given to you. Well, if I know this is 85 and I know this is 95, it has to be some number between the two. And that number is going to be closer to 95 than it is going to be to 85 because it's where the point is, and this is the high temperature on the map. So if you were to answer with a temperature of like 93 degrees, that would be okay. Even if you put 94, even if you put 92, I think those would all be acceptable because that point is closer to 95 than it is to 85. They're estimations, they're inferences, but it's based on the data that's given to you. Let's look at another example. So this is a New York State map, specifically of the upper northwest of New York State, near Lake Erie. And this is showing snowfall totals during a winter season from 1985 to 1986. And if I were to ask you to give me the total amount of snowfall in this part of Genesee County, one of your possible answers could be something like 94 inches of snow in total, because that dot is about halfway. I mean, that's really arbitrary whether or not it's exactly halfway. I think it's about 94 inches. If you came up with 95 inches, that would be acceptable too. If I asked you to give me the total snowfall at that exact dot, this one that I drew right here, it's not between two lines, it's really at the top of 150. So what would be an acceptable value? If anywhere on this line is equal to 150, inside of it, I have to be somewhere between 151 and 159. Why 159? Well, if it was 160, I would have another line drawn since this is going by 10. But I don't. So if I was asked this as a test question, I would say anything between 151 and 159. And any answer would be okay as long as it was in that range. Another way that you can use a field map is to calculate gradient. Gradient happens to be a formula on your reference table on page 1. That formula reads change in field value divided by the distance. So let's work with that formula and look at a few examples so that you feel more confident when you have to use it in class. And we'll actually use a couple of field maps. So here's a temperature field map, and I'd like to know what is the gradient from A to B. Let's take a look at what A and B's values are. A has a value of 19 and B has a value of 22. So I would put those into my formula, and I want to know the change in value. Change in value literally means difference. How much did it change? So the difference from A to B is 3 degrees. Now, I want to know the distance from A to B. And it's on a map, so I'm going to use the map scale at the bottom of the page. So that's 4 meters plus a little extra. So that's about 6 meters in distance. So I use the straight line distance between the 2 points, and I bring it down to the scale at the bottom of the page, and I measured 6 meters. And I use the formula 3 divided by 6 to come up with a gradient of 0.5 degrees Celsius per each meter. And that would be my answer. Similar to rate of change, I have to make sure my units match what's in my numerator and what's in my denominator. That went really fast, so let's try another one. Working with the same formula, these are elevations. So this is a map showing elevation, height above sea level. And the gradient we want to know is the gradient between points A and point B. So let's look at the values. Point A is 650 and point B is 300. The difference between those two is 350 meters. Now we want to know what's the distance from A to B. So same thing, I'm going to take the straight line distance, bring it down to the bottom, and that's a distance of 10 kilometers. So I'm using the scale on the map. I'm using a straight line. You can use a piece of paper or a ruler, not your fingers. And I'm bringing it down to the bottom of the page or wherever the map scale is, and I'm using that to calculate the gradient. So in this case, 350 meters was the difference, divided by 10 gives me 3.5 meters per kilometer. That's the gradient. Let's look at another example. Working with snowfall totals once again, we're going to find out the gradient from A to B, the value at A. Now we have to infer this, right? And take a look at these two values. They're not on points, as they were in previous examples, and they don't fall directly on one of the iso lines here. So we have to interpret it. So what would be an interpretation for A, and what would be an interpretation for B? I think A is about halfway between 6 and 12, which is a value of 8 inches, and B is closer to the line of 6 than it is to 1. So I gave it a value of 5 inches. Now I want to know the distance from A to B. So again, straight line distance, I'm going to use that and the scale at the bottom of the page, and I'm going to measure. It's about 40 miles. So my gradient is going to be equal to 0.05 inches per mile. And I did that by inferring the data points from the map. One more example. And now this is a new type of field map. This is called a contour map, a topographic map. And we're working with elevation here. Above sea level, we want to know the gradient from points C to D. So the value at C is 1,500 and the value at D is 1,000. We want to know the straight line distance. So we draw a line and we bring it to our map scale. It's about 2 miles. So that gives me a gradient in the end of 250 feet per mile. So what that means is if I was walking from point D to point C, the rate at which the ground increased under my foot as I walked would be 250 feet every mile that I walk. So after 2 miles, I would have completed a 500 foot climb. So that's how gradient is related to field maps. And that's how we can use that information to understand the data that we have. So that's it for now. And thanks for watching.